Welcome. Today we're going to talk about vertical line test for functions, or the vertical line test, because a lot of times we're given a graph and they're not just points, but they're a continuous line or curve. Right? There's infinitely many points. And remember, from the last lesson, I said if you ever have 2 points that are lined up vertically, it's not a function. So what we do is, if they give you a graph, like here's a graph of just a straight line. What you do is you take a ruler. I prefer see-through rulers, but what you do is you get the ruler itself, the edge of the ruler, to be vertical, and you work along the graph, moving left to right, seeing if that line ever doubles back on itself or happens to have 2 points. And that's the thing I like to think of, is the graph can't double back on itself. So basically, in a sense, all straight lines, though, are functions, except one specific type of straight line, and that's the vertical line. A vertical line would not be considered a function because, again, vertically they have infinitely many points that line up on the same x value. So a vertical line is not a function, but all slant lines and all horizontal lines are considered functions because they never arc back on themselves or come back on themselves. And what I mean by that, turn back on themselves, it's all right for a function to be curvy and to go up and down and up and down and up, because if we take that ruler and we work it along here, I never touch the graph more than once along this edge of the ruler, along this vertical edge. I'm never going to hit that curve more than once. And so it's perfectly fine for a function to go up and down, up and down, up and down. That is going to be a function. What we can't have is like this over here, where it arcs back on itself, where it goes right and left and right and left and right and left. Because then if I plug it up there, look at this point on the x-axis, I have 1 point, 2 points, 3 points, 4 points, 5 points that are lined up vertically. That means it's not a function. And technically, it only needs 2 points to line up for it not to be a function. It doesn't need multiple. It can just be a single point, or sorry, 2 points at 1 point in the graph where it lines up. Now, another thing I want to emphasize is there are graphs that approach verticalness that are functions, and some that aren't. In other words, a graph might come down and almost become vertical. In fact, this one turns back on itself. I purposely made this one that you can kind of see over the x-axis, that it kind of comes back over the x-axis. Or again, if I was to make that ruler go along there, I'm going to end up touching that curve more than once at a given x value, which means it's not a function. But you will see functions that become very vertical but are still considered functions. Now, I wrote this one kind of poorly because that actually looks like it's coming back, but it's not supposed to. It's supposed to be approaching that green dotted line. Those lines are what they're approaching those lines, but never quite get there. They get closer and closer and closer. So this function has 3 parts to it. It comes in from the left, very, very close to the green line, but never quite touches it. And then it starts to curve and it goes up and it gets very, very close to this green line, but never touches it. So it never actually becomes perfectly vertical. If I was to work along here, I never actually end up touching that line more than once, or I shouldn't be, unless my drawing or handwriting's bad. Same thing here. The second part of the function, it goes off and gets closer and closer and closer and closer and closer to that green line, but never quite touches it. So that means it never actually arcs back on itself. Same thing for this side. It never arcs back on itself. And then when we get to the third part up here, so by the way, these green lines are called asymptotes. It's what the line approaches as we go off very large or get very close to these x values, whatever they may be. If it's a 3 and a -2, they're getting closer and closer, going off to infinity. We'll talk a lot more about those later. The main thing I want to emphasize, though, is that you can have functions that look like they're almost getting vertical, but you just got to realize they're not if they have these little lines of that they're approaching. Those asymptotes is what they're called. If you have any questions, do bring them to class.